as developers, we're always like trying to push the envelope with what we can do in web apps.
Oh, yeah, for sure.
But sometimes like all the cool new AI stuff can really bog things down performance-wise.
Yeah, it's true. Those deep neural networks pack a punch, but they can be real resource hogs, especially when you're trying to run them in a browser.
Right, and that's where this new research caught my eye. It's a study in Frontiers of Computer Science about an approach called WPIA. They're claiming some pretty big speed boosts.
WPIA stands for WebGL program, immediately available, and it's tackling a big problem with browser-based DNNs. That is the warm-up time.
Okay, so for those of us who aren't like deep learning gurus, what exactly does that warm-up time mean?
Well, you can kind of think of it like this. Before a DNN can work its magic in your web app, you got to get it all set up and ready to go.
Right.
And a big chunk of that setup time is spent compiling WebGL programs into the binary code that the browser can actually use.
Hmm.
This is especially noticeable with those really complex models like DenseNet.
Gotcha. So WPIA is basically trying to make that prep work go faster.
You got it. Instead of making the browser do all the heavy lifting of compiling stuff on the fly, WPIA offloads that to the server. It precompiles those WebGL programs ahead of time so the browser can just download them and run them.
That sounds like it could save a bunch of time.
Yeah,
But wouldn't downloading big binary files create like a bottleneck of its own?
that's a really good question. And the people who developed a WPIA were thinking about that too. They actually came up with this clever merging technique that combines multiple WebGL programs into a single smaller binary.
Oh, wow.
This keeps the download size down without messing with functionality.
So they're doing precompiling, AD optimizing the file size. That's pretty slick.
Right.
But how do they make sure everything runs smoothly even though the code is already precompiled?
They use what they call a record and replay technique. So during an offline phase, WPIA records the exact order that those WebGL programs run in.
Okay.
Then when the user loads the web app, WPIA just replays that sequence in the browser.
So it's like a predetermined path to make sure everything happens in the right order, even with precompiled code. This WPIA is sounding more impressive by the minute. What kind of real-world results are we talking about here?
Well, the study tested WPIA on all kinds of devices, from powerful laptops to those simpler smartphones, and they used different DNN models too, and the results are pretty interesting.
Okay, don't leave us hanging. Did it live up to all the hype?
Across the board, they saw big reductions in warm-up time. We're talking an average reduction of 84.1%. Some scenarios even hit that 95% mark you mentioned earlier.
Wow, those are some seriously impressive numbers. I'm starting to see why this research is getting so much buzz. But before we get too carried away, I've got to ask, are there any potential downsides or challenges to using WPIA? It almost sounds like a magic bullet. There's got to be some catches, right?
Well, like with any new tech, there are going to be some challenges. One that comes to mind is security.
Yeah, that makes sense. Letting the browser just run binaries downloaded from the internet, even if they are precompiled, sounds a little risky.
Exactly, and the folks behind WPIA know that. They suggest some pretty strict security stuff, like requiring HTTPS for any web app that uses WPIA and using strong integrity checks to make sure those binaries haven't been messed with on their way to the browser.
So it's all about adding those extra layers of security to minimize the risks.
Got it.
Are there any other challenges that developers might bump into?
Another possible hurdle is the cost of precompiling those WebGL programs. Different GPUs use different binary formats, and to make WPIA really universal, you'd want to precompile for a bunch of them.
I see where you're going with this.
Right.
Wouldn't that mean needing access to a whole bunch of different hardware, which could get pricey?
You're right. But some GPU companies offer offline compilers that can make those binaries without actually needing the physical hardware itself. And in some cases, you might even be able to crowdsource the precompiled binaries right from users' browsers if their browsers can pull them out.
That's pretty clever. If that works reliably, it could really cut down on the cost and hassle of using WPIA.
It's definitely a promising idea. And remember, even though there are challenges, the potential benefits of WPIA are huge, especially for developers building AI features for the web. It could let us create those more sophisticated and responsive apps without being held back by performance issues.
This whole approach feels like a real game changer for how we think about AI in web development. It's like we're taking those really demanding tasks and moving them off of the user's device and onto those more powerful servers.
You nailed it. WPIA is all about using resources smarter in web development. It lets us tap into the power of servers to create those richer user experiences on the client side. And this is super important because we're seeing more and more demand for AI features in web apps.
It's like we're setting the stage for a future where AI is just seamlessly part of everything on the web without sacrificing performance or user experience. What I find really interesting is what this could mean for developers creatively. With WPIA handling all the technical grunt work, what kind of doors does that open up for us?
That's a great question. The possibilities are pretty exciting. Just imagine a web where those fancy AI features aren't only for high-end devices or special apps.
Yeah, we were talking about like personalized shopping and those AI tutors, but like where else could this go? What are some other areas where WPIA could really make a difference?
Well, imagine like real-time language translation happening right there on any web page, breaking down those communication barriers all over the world.
Right.
Or picture those complex 3D visualizations powered by AI becoming super common in e-commerce, letting customers actually interact with products in totally new ways.
Those are some really cool examples. But it's not just about like making things look flashy, right? We could
Mhm.
also use WPIA to make the web more inclusive and accessible for everyone.
Exactly. With the performance boost that WPIA gives us, we could seamlessly integrate AI-powered features, like real-time audio descriptions of web pages for people who are visually impaired, or predictive text input for people with motor difficulties.
It's pretty amazing to think that this technology could not only make the web more powerful, but also make it a more fair and accessible place for everyone.
It really shows how technological advancements should be about more than just speed or efficiency. They should be about empowering people and making the online experience better for everyone.
I totally agree.
Yeah.
So for our listeners who are now like super excited about WPAA as we are, where can they go to learn more?
The full research article with all the technical nitty-gritty is available in the Frontiers of Computer Science journal. And like always, we'll put links to that article and all the extra stuff, including the researcher's prototype code, in the show notes.
Definitely check those out. And if you come up with any cool uses for WPIA, we want to hear about it. Share your ideas and projects with us on social media using the hashtag #DeepDiveWPIA.
We're always stoked to see how developers are using new technologies in creative ways to push the limits of what's possible on the web.
And that's a wrap for this deep dive. We hope you're leaving with a sense of like wonder about the future of AI on the web and a bunch of ideas about how WPIA can help you build those next-gen applications. Keep coding, keep learning, and keep exploring. We'll catch you on the next deep